This video is attached to the October 16th remote class. For this week, we have done our first deep dive into analytical tools, spatial modeling tools for Arc Pro, and in particular, we are focusing on how to modify geographies. And so, we learned some fairly basic ones last video around clipping and erase. And for this video, we'll learn sort of their, older siblings, the sort of more grown-up versions of modeling geometries, and they are intersect and union. Now, it's been a long time, I'm sure, since many of us have had our geometry classes. But if you can think back to those old days in high school, you may remember the terms intersect and union, right? The law of intersect and the law of union. The law of intersect states the area where there is only overlap, right? So an intersection is only going to show you or try to bring back the true area where 2, 3, 4, 5, 6, a million things meet. Union shows you all of the areas of individual overlap. So union might show you where one boundary overlaps boundary 2, and another where boundary 2, 3, and 4 overlap but not 1, and the area where 1, 2, 3, and 4 overlap. They are companions to one another. They are extremely useful tools. They have weird outputs. And so I'm going to try to carefully walk you through what their outputs look like. In my experience, these tend to be the tools that when people are first learning GIS, the outputs can overwhelm you and therefore you don't want to deal with them. And I'm telling you not to do that because these tools are invaluable to modeling geometries in a way to see fascinating results, that you could not see otherwise. And, in order to get there, it's just a tiny bit of muscle work to interpret sort of what the outputs look like. So should you choose to follow on this video, I'm using data from the Intersect and Union toolbar. What these actually were was from a few years back when I taught at Jefferson. I had students draw what they thought Center City was, for Philadelphia, and obviously, got back a variety of crazy answers, all over the place, which I think, proves that point that I was trying to make with the lesson that, neighborhoods are sort of subjective boundaries. And we will likely do a similar exercise to this together for the in-class next week. So, potentially expect an email from me asking you to do something similar. So what I'm going to want to do then is maybe see two questions I'd want to answer with this fascinating piece. Is there an area where they all agree? And if so, where is the area of pure overlap and pure agreement, right? How big is it? Where is it? So on and so forth. And then the next thing I'd maybe want to know is where are the areas where some of them agree, but not all, right? I mean, if I click here, right, just with my select, or I drag my select here, right, I might be selecting sort of multiple things, right? I might be selecting this interior, but also this large one out here. If I were to come and select, slow computer right now, if I were to come and maybe select this right here, oh, goodness, take your time, why don't you? I'm going to be selecting sort of everything that overlaps that. I'm selecting sort of multiple different shapes. So, there's clearly different areas of overlap, and maybe that would be fascinating. Union is a really cool tool that for example, if you're, looking to, engage in real estate development in a neighborhood, and you want to be sort of respective and informed of the community groups, you could find the boundaries, that every sort of community group focuses on and union them. And you could start to see the areas where there's 2, 3, 4, 5, 6, 7 who sort of claim agency over a community and a neighborhood, and sort of know who you would have to work with. So let's see these in effect. So come on up to analysis, come on to tools. Intersect and union are in the overlay. And we'll start with intersect because it's sort of a little bit straightforward, or more straightforward, and then we'll go from there. So intersect, again, what you are doing is you are dragging in multiple values here, And from that, you will then get a return value of where they all overlap, right? So notice each time I drag in a layer, a subsequent layer comes. So that's nice. Badoop, 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 badoop. We keep growing, and we're growing and growing and growing and growing. I should have my 6 right here. Should this tool fail, it will only fail if there's not an area where all of them overlap, right? So if you ever run this and the tool gives you nothing back, just know the reason that it gave you nothing back is that it had nothing to offer. So I'll just maybe call this my intersect. My intersect 1 maybe. And this is a super critical field. And this is what allows this tool to sometimes overwhelm people. And so I'm going to actually first run it with all attributes, and then we're going to run it again with only feature IDs. And I'll show you sort of how that gives 2 different results. And then you can make the determination about which one you think is the most useful once you can interpret them. So we'll start with all attributes. Keep the output type same as the input for now. I'll show you when that might be, good to change. And hit run. And boopity 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 boop. We'll do its thing. We got a thing that comes up. There we go. We can sort of see it. It, of course, takes on the same color, which seems to be this new fad with Arc. I'll change it to something new. And here we are, the area where there is true overlap, right? This is the only shape where all 6 of these are on the same agreement. And I can open its attribute table, and this is where the confusion begins to set in, because what this will do is it literally takes everybody's attributes and just smashes them into each other. Now, if you know how to read this, it starts to make sense, right? Name ID, well, that came from CC Student 3, right? So if I open Center City Student 3, I can see, oh, yeah, they did. They had an OID, a name ID, a num ID, the length and an area. Well, Intersect just took that, right? OID, name ID, num ID, and then the shape length and the shape area. Then it got onto the next shape it was going to do, which was Student 2. Well, lo and behold, those attributes are the same, right? So it can't have the same value or name, so it just added 1, right? Hey, OID 1, name ID 1, num ID 1, and on and on and on, right? So it just sort of appends all of the information here. Now, this can be useful when you have a large number of intersects, and in future lessons, perhaps when we are trying to synthesize and use this as a data management tool, I'll demonstrate that. But often when you're learning it, right, if you don't need to see the exact sort of levels of intersection, if all that matters to you is really the geography that they intersected, you might want to make it simpler on yourself and put only IDs. It just sort of limits the number of fields here. And I'll name this intersect 2. Run it. And if I open that one, it just takes away sort of most of the fields except the FID. So now you'll just get, the 6 FIDs, right? We each had an FID, blah, 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 blah. 1 means that we found an overlap. Nice and simple, nice and easy. So that's intersect. Union will give us a very different result. Union will start to turn this object here, this weird little point, into its own shapefile, because this happens to be an area where this thing exists, but it doesn't have an overlap with this, and it doesn't have an overlap with that. But that would change when I get here, and suddenly multiple things start to overlap. So let's see how union would work. And I'm going to do the same thing with the attributes. So I'll drag in all 6. We'll go 3, 2, 6, same as we did last time. 1, 4, and 5. And I'll just call you my union, because that's what you'll be, the first union. We'll keep the all attributes at first. I actually think the difference here between using all attributes and FID only is even more important for sort of union. And I'll sort of show you when it's appropriate to use both, but let's start with all. And here I actually want you to, gaps is an interesting one. Gaps sort of means, that when you create this, like there's actually going to be a weird instance where this thing ropes around and sort of loops with something on multiple points. So it might look like the same shapefile is split in half. You can choose to sort of get rid of those gaps by experimenting with it or without. I usually keep it clicked as my default. XY tolerance is sort of big on this one. Now, often when you're unioning, you're probably going to be unioning irregular shapes. And it's the same thing here. Like, I guarantee all of my well-meaning students all meant for the Schuylkill River to be the boundary, the western boundary here. But they all took different approaches to how exact they were in drawing it. So I sort of know that, like, that's a true boundary, right? I mean, like, that they all are meaning to be the Schuylkill River. But it's creating these weird things like where it's going to try to show that, like, this ridiculous sliver here is one student's interpretation that another student didn't. Well, that's not true. That's just an error because they didn't draw things as accurately, right? And it's not a big one. I could measure the distance between that. It's roughly, a good 180 or so feet. And so that's what this thing maybe allows you to do. I'll see sort of what the same sliver is over here. 500 or so. And, so what you could maybe do is put in some tolerance. Like, what if I said, hey, look, I know that maybe within 350 feet there's a margin of error. And all that'll do is sort of shrink the boundaries by that so that if it finds overlaps within that contingency, it won't treat them as real overlaps. You won't get that problem where, like, this sliver is treated as a separate unioned area. You'll only be looking at sort of the big shapes. So I'm going to turn all these off, so that what comes back is fairly easy to interpret. I'll run it. And what we have is what appears to be sort of a puzzle here. Now, let's break apart what we're looking at. The first thing I want you to do is come up to Appearance, go to Symbology, pick Unique Values, and we're literally going to take, not going to let me have my own FID, so that one's not going to work like I wanted. So let's just go away from that one. Go back and make this sort of an orange or something. Let's open the attribute table and take a look at what we built. And this looks very different than what we had seen in the past. What you can sort of see now is the way that each row is structured. It tells you who actually had an area of intersection there. And right, for this first shape, which I can't see, so maybe let's pick this one here in the center, 6, which ends up corresponding with this little sliver down here. That sliver, Center City Student 3 is there. All right, Center City Student 1 is there. Center City Student 4 is there, but nobody else. Versus I could click on this shape in the middle, which I knew was the intersect. And that would tell me all of them, right? All of them are going to have their values. Hey, Center City 3, I'm here. Center City 6 is here. Center City 1 is here, so on and so forth. So really what it's telling you here is it's effectively telling you the areas of overlap, right? All of the areas, or the people who have the overlap, all of those unique areas are codified within what comes back in the field. So you can begin to see where one student, student 1 and student 2 agreed, where student 1, 2, and 3 agreed, and so on and so forth. And notice that when there isn't an overlap, you do get this -1, versus a 1. And so this is something I think worth looking into a little bit more. So let's run the same tool here, but let's choose that only your feature IDs. And I'll call it a union 2. And turn this one off and run it. And now it becomes a little more manageable, right? There's negative ones when there wasn't, and there are just ones when there was. So, right, we can begin to see, this shape here would have had two students agreed, right? Only 2 students agreed on that because there's 2 ones and the rest are negative ones. This shape right here, which corresponds with that sliver, did not, but yes, so there's 1 student, 2 students, 3 students. 3 students sort of agreed on that. This little sort of sliver in here, 1 student agreed. Agreed, didn't. So it's giving you a cleaner way maybe to see the number of overlaps. And you could do some sort of, modeling with Field Calculator. I don't want to give it away in this video. I'm hopefully going to try to tease this out during the in-class lesson. But you could play around with Field Calculator and actually create a new field which maybe told you total number of overlaps using just this value. And then you could begin to symbolize this as something new. You could begin to symbolize this as a layer of agreement, right? Where did students agree that Center City was? Where did 50% of students agree? Where did 25%? So that's union, right? If you care about all areas of overlap and you want to know who and what overlaps in each given segment, that's when you would use union. Intersect you would use when you only want to bring back the shape that is the true area of overlap for every single shape.